So let's start the session, guys. So we are actually in the information system in digital environment chapter, and we are focusing on this chapter one concept of information system, and it is impact of information systems, right? So the first things we have to see the information system, and after that we will learn about the impact, right? As you know, the learning of outcomes are differentiate the data from the information and describe the characteristic of quality data and identify the fundamental components of an information system and describe their function. So according to that, so now we have achieved our first learning objectives, that is differentiate the data from the information. As well as I have mentioned to you, the data versus information, the differentiation you have to produce in a tabular format. That's very important, high value exam area. So we have achieved these learning outcomes and describe the characteristic of quality data. Also, we have seen in the next previous session. So in the previous session, we have seen what are the qualities of a good information. Actually, not describe the characteristic of quality data. It should be quality information, right? So we have seen that one, and in today's session, we are going to achieve other learning outcomes also. So the chapter topics, almost 14 chapter topics are here, and we have completed this data, information, and knowledge area, and difference between the data and information. So this table is high value exam area. So you have to memorize 4 or 5 differentiation as per in the table. So they will test in your examination. So the characteristic of good quality informations are, we have seen 8 good characteristics. This is also one of the pure exam area. So understandable, relevant, complete, available, reliable, concise, timely, cost effective. So you have to talk about this as a definition as well as examples, right? According to the marks allocation, we will write. And in today's sessions, we are going to focus from elements of information systems, right? So elements of information system means, my dears, we are going to understand what makes up an information system. What makes up an information system? Like understanding that a bicycle has wheels, chain, handlebar, seat, pedals. Like that, we are going to understand the elements of information system, right? So let's start that topic where we will study about what is system and system components, their terminologies, and what are the types of systems and complex systems. And there are some model called IPO model, that is input, process, output. That's we consider as a IPO model. We will study about this. And after that, we will study about information system definition. Okay. So what is a system? So, system in the sense, my dears, before we understand information system, right? That is our actual topic, information system. So, before we understand information systems, we need to understand what a system, right? Is any system, in any system. It can be information system or other kind of system. What is actually a system means? So, see the system definition here. A system is an organized collection of parts or subsystems that are highly integrated to accomplish an overall goal, right? So that is the pure definition. So what we are trying to make here, it's a system. A system is an organized collection of parts. So collection of part means there are some subsystems. So a system is collecting some subsystems that are highly integrated to accomplish an overall goal. Integrated means it's connected with one, right? In the picture, you can understand these are like a subsystem. So it is connected with each other to create an entire system, right? So think about this in a simple way, my dears. A system is like a cricket team, right? There are some parts, right? 11 players are there, coach will be there, umpire, cricket ground, equipment. What's the goal? To win the match. Like that, an organization, they might have goals. To accomplish that goals, they have subsystems. So that subsystem, and if we collect that subsystems, we can create an entire system. So the integrations means all parts work together. If one player is missing, team can't play properly. If ground has no pitch, we can't play the cricket. So everything must work together to achieve the goal. So that is what the meaning of a system. So collection of subsystems or parts that are highly integrated with each other to accomplish an overall goal. And let's see the key components here. So the key components are here, my dears. There may be various inputs, right? And certain processes will be there, certain outputs there. Together, accomplish the overall desired goal. What's this means? Simply, my dears, in systems, we will have something called input, right? Any systems, we will have inputs. As you know, the input we will process and output, it will be the goal, right? So that is actually a system. So we can consider in any system there will be some inputs. So inputs means what goes into the system. Actually, if it is a system in this image, what goes into the system is inputs. As well as there are some certain processes. Processes means what the system does. Actually, the process you can see in the gear icon, right? What the system does, right? As well as there will be some certain outputs. The outputs are what comes out from the system. So together accomplish the overall desired goal with the system. So that's the meaning of the system, and these are the key components here, right? So let's say, for an example, if you guys are doing hopper soap system, let's say your name is Fatima, so you make and sell very delicious hoppers to customers. What are the parts of your systems? In your system, you will have some inputs like rice flour, coconut milk, salt, eggs, and firewood and water. And you will do process like, you will mix the flour with the coconut milk and you will heat the hopper pan and you will pour some butter there and you will cook until it's become a crispy, right? And you will add some egg if customers want. That's how it will be. The output is going to be, delicious hot hoppers. So customers are happy. Fatima can earn money. So why we are calling this is an system? Because all parts work together. Each part is necessary. If you remove any part, the system fails, right? Right? So I hope so you understood the concept. So simply, my dear, system is input, process, and outputs. It integrated with the several subsystems. So the important principle is here. A system is usually made up of many smaller systems. As I mentioned earlier, if there's a big system, it's a collection of subsystems. That's what we are saying. A system is usually made up of many smaller systems. It means there will be so many subsystems. We have to function that as a main system. So if one part of the system is changed, the nature of the overall system changed as well, right? Simply, my dears, think of Kiel supermarket system. It's a very big system, right? The whole supermarket is a big system. What are the subsystems inside? The cashier, they are having some system like cash registers, receipt printers, barcode scanners. They have separate system. As well as inventory management, it's a separate system. The products on shelves, storage warehouses, delivery trucks are coming. That is inventory management system. And staff handling system. Staffs have cashiers, security guards, managers, cleaners, as well as customer management system. They have shopping carts, shopping baskets, customer service desks. So if you change one subsystem, the whole system will change. Let's say Keels remove the cashier system and add self checkout machines. So the whole system is changing, right? Whole supermarket experience will change. They will need very fewer cashier staff. Customers do more work themselves, right? They have to go and scan the barcode, and sometimes customers, they will, they are not scanning and they will take out the goods. It is faster for some people, but some, low level knowledge people, it's confusing. So this is the important principles. If one smaller system is changing, the entire system has to change. So now you got a very good understanding about the meaning of system. And let's talk about the system components or elements or terminologies. So we will talk about some terminologies here. The first terminology is components, right? So if it is a system, as I said earlier, there will be components. It means subsystem. So an irreducible part of or aggregation of parts that make up a system, also called subsystem. Simply, as I mentioned earlier, a system is a collection of subsystem. So components, in the sense, we are considering the subsystems, right? It means the building blocks of a system, the parts you can't break down anymore. That is components. Let's say, for an example, three-wheeler. It is a system, right? It has engine. You can't break this down further and still have functioning engine, right? That is, engine should be there, and wheels, that's the basic part, and there should be a steering and seat, frame. These are basic parts. So each is a component. Together, we make the three-wheeler system. So that's the meaning of components, right? As well as interrelated components. What's the terminology meaning here? Interrelated components means one subsystem is connected with other subsystem, right? That's the meaning of interrelated component. It means dependence of one part of the system on one or more other system parts. So the important keyword is here dependence. So one subsystem is depend on other subsystem, shows an interconnection between the parts, right? So this is about interrelated components, right? It means parts, it doesn't work alone. They depend on each other. Like, our brain needs our eyes to see, our legs need our brain to move, right? So our brain is connected with the legs, and our eyes is connected with the brain, and brain connected with eyes and legs. So this is very interrelated component. Like that, interrelated components means subsystems are connected with each other, right? I hope so you're understanding with me. Let's say Ahmad's restaurant is a system example, where there will be a component like kitchen component, like kitchen subsystem, where food is cooked. And there is another component or another subsystem like waiters who serve the food. And there will be another component like cashier who takes the payment. How they are interrelated? Kitchen, they makes the food. So waiters need kitchen to have a food to serve, right? Otherwise, how can? And waiters, they serve the customers. So cashiers needs waiters to know what customers ordered, as well as cashiers takes the payment, because kitchen needs cashier to know which orders are paid. So it is very interrelated, connected. What happens if one part fail, my dears? Kitchen stop working, waiters have nothing to serve, customers leave, cashier has no bills to collect, whole system fails, right? That's what I'm saying. It's very interrelated. It means everything is connected. That is interrelated components. And let's talk about the term boundary, right? So boundary in the sense, my dear, the line that marks inside the outside of the system. It means for any systems, we have to put a boundary, right? So this is our boundary. We are working within this system. So the line that marks the inside and outside of a system, right? If you are putting a line and it marks the inside as well as the outside of the system. In this picture, you can get more example. We are drawing this line, right? So beyond this line, this is outside. Within this line, that is inside. So it sets off the system from its environment. So this is the environment, this is the system, right? So I hope that you are getting my point, my dears. If you have any questions, please let me know in the chat box. So the border of your system, that is the boundary. So what's included and what's outside. Think of it like this. Your house has walls and fans, right? That's the boundary. Your fans and walls are boundary. Inside your house system, outside your neighborhood environment, right? That's what in the system we have boundaries always. As well as in any systems, we will have some purpose, the overall goal or function of a system, why we are having that system, what the systems aims to achieve. That's the meaning of the purpose actually, right? So the overall goal or function of a system, why does the system exist, what's it's trying to do. Let's say hospital system, they make sick people healthy, right? That's their purpose. So school is a system. What is their purpose? They are educating the students. And restaurant, it's a system. What's their purpose? They are feeding the hungry people. And bank is a system. They keep money safe and help with the transaction. That's their purpose. And three-wheeler is a system, as I mentioned earlier, transport people from place to place. And dialogue, a company is a system. They are provide communication services. So every system, they have a purpose. If it doesn't have a purpose, why we have to have a system itself, right? So every system, they will have a purpose. And let's talk about the environment. So environment, everything external to a system, it means beyond that boundary line, right? So external to a system, we call that as a environment that interacts with the system itself. So external factors are affecting the systems usually, right? So the world around the systems that affects it, but it's not part of the system, that is the environment, right? Let's say if you are running a three-wheeler business, let's say your name is Ismail. So Ismail's three-wheeler system is a system. So what is the environment there? Weather condition, that is outside. That's an external thing. So if it is a rainy season, fewer customers want to ride, right? They take the bus sometimes. And traffic is an external environment factor because Colombo traffic jam, it will takes longer. So customers are unhappy. And fuel prices, that is also external environment because petrol prices are goes up. Ismail's cost of operating the three-wheeler is increasing. As well as we'll talk about competition. Other three-wheelers competing for customers, right? That is also from external environment. That is, outside the boundary of the system. As well as governments are putting new rules, new meter rules, new traffic laws, as well as economy. If people have less money, it means they have less purchasing power. They take bus instead of three-wheeler. So this is environment. And also, my dears, this environment affects the system actually. Let's assume in a hot sunny day, more customers won't ride. Ismail also busy because he is riding the three-wheeler. In rainy day, fewer customers. Ismail is waiting for customers. If petrol prices doubles, Ismail must increase the fares, the prices. So they will lose money. And traffic police is nearby. Ismail must follow the rules very carefully. So, as an owner, Ismail can't control the environment, but he must adapt for the environment. So, every system has environment also, right? And let's talk about the interface. Systems have interfaces. So, interfaces, my dears, it's a point of contact where a system meets its environment, right? That's the meaning of interface. It means the meeting points, the connection points, the places where things interconnected, right? It's like, in the mobile phone, the screen is an interface, right? There are a lot of hardwares are there, a lot of softwares are there. So the interface between you and your phone system is the interface, right? So the meeting points, the place where things are interacting with each other. Let's say, think of it in this way. Your mouth is the interface between your body and the food, right? Your body is the systems. Your food is the environment. That's an external thing. Your food is the environment that is external. Your body is your system. So your food and your body is interconnected with your mouth. You can eat through your mouth only, right? And also, let's see Keel supermarket interfaces. There are interface. Number one, customer service desk is there, where customers they can meet the Keel system. Customers can return the items, ask questions, make complaints. That is one interface. Customers are from external. As well as there is a delivery gate where suppliers meet the Keel system. Right? Suppliers they will bring new stock. Keel staff check and accept, and they will produce good received notes, right? As well as there is another interface in the Keel supermarket, cash register, where customers from environment, right, are external. They will pay for the items, where the Keel system is receive the money, as well as the Keel supermarket website, where online customers they can interact with the Keel system. They can browse the products, place the orders. So each interface is important. If interface is bad, whole system looks bad, right? If there's a bad interface in the Keels, customers comes to Keels, they can't find the customer service desk, they can't find the staff to ask questions, they're frustrated, customers will leave the organization, right? So that's the meaning of interface. As well as in some systems, they are having some constraints also, my dear. So constraints in the sense, a limit to what a system can accomplish, right? We cannot accomplish everything with one system. There is a limitation. It means restriction on system capabilities. We call that as a constraints. So constraints in the sense every system has limits. It means the things it can't do, no matter how hard you tries or how hard the system tries, it has own capacity limitation. Think of it like a cycle, bicycle. It's a system, right? It has constraint. You can't fly with a bicycle or motor bicycle. There's no wings. That's a limitation. You can't carry 10 people in the bicycle. No, it's very too small. You can't go like a 150 km per hour like cars. No, because not powerful enough. These are the constraints. The system has its own limitations, right? So let's talk about the another terminology in systems, inputs. So every system, it will have input. Inputs means, as I mentioned earlier, what goes into the system. So information that enters into the system for processing. The raw materials for the systems are the informations. That is the input. So information that enters into the system. What goes into the system, right? Let's say if it is a bakery system, what are the inputs? The flour, eggs, sugar, butter. If it is a school system, students are the inputs who need to learn. A restaurant system, raw food, hungry customers are the inputs, as well as factory raw materials, electricity workers, and hospital patients, sick patients, and computers, the data you type, and the electricity. So if there is no input, there is no output. If you give bad input, you can get a bad output. If your information or the input is in a very good quality, you can get the outcome as a good quality. So there will be input in the system as well as output. So output means that's a main objective of a system, right? Output is very helpful for the user. That's the final outcome of the process, right? So what comes out of the system, that's the actual final result. That's the reason the system is exist. In the bakery we are putting as an input flour and eggs, and we are mixing and baking with the process, and the output is a very fresh bread. In the school, we are putting the students, uneducated students, and we are teaching. That's the process, and the output is going to be a very well educated students. In the restaurant, the input is a raw food. The process is we are cooking with chefs, and the output is very delicious meals. In hospitals also, the input is very sick patients, and we are processing with the treatment and hospitality facilities, and the output is very healthy patients. And three-wheeler, the passenger at a point A is the input. We are driving, that's a process, and passenger at a point B, he prefer. That's the output. So output is the actual purpose. That's the goal of the system, idea. So I hope so. You got a very good understanding what are the components in the system. In any system, these are the components we are going to have, right? So I hope so. You got a very good understanding of these terminologies or components. And now, with a good understanding of system and subcomponents and what are the elements, we are moving to the topic called types of systems, right? So types of system means, my dear, systems comes in many varieties. As I mentioned earlier, there are a lot of systems. Like how there are many type of vehicles like car, bus, bicycle, three-wheeler, train. The systems also range from simple to complex. There are numerous types, right? So we are going to see the types of systems here. The simple to complex systems, biological systems, mechanical systems, humans or mechanical systems, right? It's human systems as well as ecological system, social system. So biological systems means example the heart, the natural living systems in our body, right? Let's think about this. That's a heart. That's a natural living systems. The human heart, right? Heart and blood circulation is the whole system. There are components. Heart is there. It's pumping the blood, and blood vessels are there. That means the pipes. Blood is there. It's a fluid, right? The lungs, oxygen source. Those are the components. What's the process of the heart? Heart pumps the blood. Blood carries oxygen and nutrients. Blood travels through the vessels, right? It returns to heart again. The cycle continues. What's the purpose of the system? Keep the body alive by delivering the oxygen to all parts. Otherwise, our body, we can't live, right? That's a very simple example. Your heart is like a water pump in a well. Pump pushes the water, pipes carry the water to the house. You use the water. Empty pipe again returns to well. Pump pushes water again. So that's the biological system we have in every humans. That's also a system. And mechanical system example is a thermostat, machines based systems, right? That is mechanical. It means the system made of machines and mechanical parts, right? Thermostat means a temperature controller, my dear, right? There will be temperature sensor as a component, control panel, AC unit, power supply, right? Let's say you set a temperature at 25 Celsius. Sensor measures the room temperature. So sometimes the room temperature is 30 C. So system thinks, okay, it's too hot. We need cooling. So AC will turns on. Room cools down to 25 C. So the system thinks it's a perfect temperature now. If you turns off the AC, you can serve the electricity, right? So the purpose is maintain very comfortable temperature automatically, right? So that's some mechanical systems, the AC units, as well as human systems like riding a bicycle, a combination of human and machine. So human or mechanical system means there is a combination of machine as well as a human, right? That's a human and mechanical system where the humans and machines work together. Let's say riding a bicycle is in the picture, person also here and bicycle also here. Bicycle is a machine, person is a human. So human is providing the power like steering and balancing, right? The mechanical is the frame, the wheels, the chains, the gears, how they work together, my dears. Human, they pedal, right? They will pedal. The pedal means the chains moves, so the wheels can run. So bicycle moves. So human, they can steer, handlebar turns, front wheel turns, bicycle, they can change the direction, as well as human balances there. So they can balance the bicycle, so stays upright. So both need each other, right? Bicycle without him a human, just a metal sitting in the home. Human without bicycle, it's just, you can walk. So human plus bicycle only, a minimum fast and efficient transport. So this is also one of the example of system, as well as we can say ecological system. So ecological system means a predator or pre-relationship environmental system. Simply, the systems in the nature, like how animals, plants, as well as environment work together, right? Let's say, let's talk about the Gulf Fort area, like wildlife area is there now in the Gulf Fort. There are components, small fish in the sea, big fish, right? And fishermen's, water quality, food supply. How it works, the system? If there is many small fish, big fish have food, and big fish population grows. That's an ecological system created by the nature, my dear. How beautiful it is. And if there's a many big fish in the system, they will eat too many small fish. So small fish population will decrease. If fewer small fish is there, big fish have less food. So big fish population is decreases. If there is a fewer big fish only, small fish population grows again. So the nature is balancing the ecosystem. It might be natural, it might be God or whatever. That's an ecological system. And social system examples is like groups, supply and demand, friendship, human interaction system. These are social systems we have. Systems involving with people and interacting with each other, right? Just think about a groups, a wedding in Colombo. There's a wedding ceremony system. The components are bride is there, groom is there, families, guest, photographers, caterer, marriage registrar, and venue. There is a social interaction. Families negotiate the details, guests congratulate the couples, people eat together, they socialize, photographer capture the memories. Everyone plays their role, right? The purpose is they have to unite two people and celebrate that with a community. That's a social system. So marriage, weddings is a social systems. And supply and demand, in the PETA market, there's a vegetable market in PETA. What are the social components are there? Vegetable sellers are there, customers are there, middlemen, like who bring the vegetable from the farmers, and the competing shops. That's a social component. How they work. If there's a high supply and lower demand, many vegetables but very few customers, the price will drop because they have to sell even with a less price. Otherwise, the vegetable will damage. And if there's a low supply with a high demand, it means very few vegetables are available in the market, but there are many customers. The price will rise because they have to earn more money by giving the vegetables only to the people who are ready to pay more prices. And sellers, they will compete with each other, try to attract the customers by better prices, by better quality. And customers also, they will compare. They will walk around and they will find the best deals for them. That is social system. So, my dears, whether we know or not, we are in the system. So the system is range from simple to very complex. There are numerous types of systems. And let's talk about some complex systems, my dears. So complex systems means it's very complicated. It's not a simple system, right? So some systems are very simple, like, just like a hammer. Just it will hit the things. That's a very simple system. But some systems are very complex. There are many subsystems, many parts, they all working together in a complicated ways, right? So we can see the characteristics of very complex systems. It will have very comprised numerous subsystems. There are a lot of subsystems are working together, right? As well as subsystems arranged in hierarchies manners, right? So one system and again another system like that, as well as integrated to accomplish the overall goal, as well as each subsystem has its own boundaries. So these are the characters. Let me tell you one story to understand this complex system ideas. Again, I'm taking an example of Keel supermarket chain in Sri Lanka. That is a very complex system. Let's break it down for you. The main system is what? The Keel supermarket chain. What are the subdivisions or subsystems at a level one? right? Because there are so much hierarchy, at the level one subsystem, like major divisions, like retail store division, supply chain division, human resource division, finance division, marketing division, IT division. This is subsystem in the level one. And in the level two, they are breaking down the retail store. Let's say in the retail store division, there are Colombo region stores, Kandy region store, Goal region store, other regions. Again, in the subsystem level three, if we break down one store, let's say Colombo region store, then in the Colombo regional store, there will be checkout system, there will be inventory management system, customer service system, security system, cleaning system. Even if you break down subsystem level 4, let's say we are taking the subsystem level 3 checkout system, and if we break down further, in that checkout system, cash registers, barcode scanner, payment processing, receipt printing, queue management, see how complex. There are many layers, many subsystems, but all are working together. That is the characteristic of complex systems. So components of each systems, in each system, whatever I'm talking about is in each system, subsystem, it will have input, it will have process, it will have their own outputs and outcomes. All right. So let's take one system and break it down, completely. Let's say subsystem of Keels checkout system. That's a one subsystem. So what are the inputs? Customers with items to buy, and there are product barcodes, and the cash or card or mobile payment system, and there are electricity to power the machine. Those are the inputs about the checkout system. One store in the Colombo fort, imagine. And what are the processes? They will scan the items, they will calculate the total, they will apply discounts if you have loyalty cards, and they will accept the payment, and they will print the receipt and put it on the back. Process. And what about output? Output is they sold items. Customers are happy with the receipt, money in the cash register, sales data to the main system is ready. What are the outcomes? Outcome means revenue for the store. Inventory decreases because systems know the products are sold, so automatically it reduces. Customer satisfaction is the outcome because of fast service. So each component of a subsystem, it has its own input, output, process, right? Outcome, right? Now let's talk about open systems. It means it's interact with their environments, exchange information and resources. That's the meaning of open system. Can you remember in the business environment, my dears, I told you business is always an open system because we are taking the input from the external environment and we are selling the output also to the external environment. So always the business is an open system. It means open systems are not isolated, they communicate with the outside world. Let's say dialogue telecommunication, it's an open system. Why? Because inside dialogue company internal, there are employees, there are office buildings, there are computer servers, there are cell towers. These are internal dialogue inside the dialogue company. What about the external interactions? It means with the environment. Customers are external, they pay bills, they use the services. The suppliers who are providing the equipment like Wi-Fi routers, right, they are external interaction. And government, they issue the license and regulations. And competitors, other telecom companies nowadays, Starlink is compete with Sri Lanka telecom communication by providing unlimited internet connection, high speed internet connection. Like technology companies, they provide software updates. Like that, every business is an open system. They are exchanging the information, and they are interacting with beyond the boundary. It means with the external environment. So always a business is an open system. How they are exchanging the information? Let's say customers call to complaint, dialogue learns about the problems and dialogue fix the issue. Government issue a new rule, dialogue must adapt that rule. Competitors are offering a better package, now dialogue must compete with them. So they have to interact with the environment to survive. That's the meaning of open system, my dear. Okay. And high functioning system. So we are moving to the another topic, high functioning system. What this means in simple words? It means, my dear, a good system constantly checks itself. It will check itself, it will fix the problems, and it will stay focused on its goal, its purpose. So continuously exchange the feedback among the parts, right? And parts remain closely aligned with each other, focused on achieving the system goal, and makes necessary adjustments when it is needed. That's a high functioning system, right? So let me tell you one practical example, my dears. Let's take Arpico department store. It's a very high functioning system. How? They are exchanging the feedback first, continuously exchange the feedback among every parts. Let's say product is not selling, right? So the inventory system reports say, okay, blue shirts 500 units not selling. It is still it is in the stock. So system will alert the manager. Manager will check, okay, why not selling? Is it a wrong size? Is it a wrong color? Or it's very too expensive? Right. So they come for the decision, okay, we will reduce the price to 30%. So the sales system reports is coming, okay, blue shirts are now selling well. Now the feedback loop is worked, right? That's what continuously it's exchanging the feedback among the parts, right? That's a high functioning system, right? And let's say another scenario, long customer queues are in the Apico supercenters, right? So CCTV shows, right, like long lines at cash registers. So manager sees that, okay, too many customers, but not enough cashiers. So manager opened three more registers, cash registers. So the queue length is reduces. Customers are happy. So now the adjustment made based on the feedback from the system. Let's say air conditioning is failure. Nowadays the temperature sensor is 30°C inside the store, but it's too hot, right? So system alerts the maintenance department, and maintenance checks, okay, the AC broken, and maintenance fixes the AC. Now the temperature returns to 24 Celsius. Customers are very comfortable again. The system itself corrected the things. So that's the meaning of, my dears, continually exchange the feedback among parts. A system should continuously exchange the feedback of what it's trying to achieve. It's a failure or what's a correction. And parts remain closely aligned. What this means? All parts of system work together toward the same goal. As I mentioned earlier, it's not fighting each other, right? The parts remain closely aligned. Let's say a bad example. Marketing department, let's offer everything at half price. That's their proposal. Finance department saying, no, wait, we will lose the money. Don't offer at half price. So marketing department is fighting with finance department. And operation department, they said, we can't handle that many customers. We don't have staffs. So if the parts are fighting, it means if the subsystems are fighting, then the system is going to fail. Let me tell you one good example. If the parts remain closely aligned, company goal is increase the customer satisfaction. And the marketing department, they creates very friendly advertisements. And the staffs are very trained to smile and help the customers. And operation staffs, they ensure, okay, we will, whatever the customer, how many customers are coming, we will ensure the fast checkout. They are committed. And finance department saying, okay, budgets for enough staff. We have budget. So if all parts working toward the same goals only, the system will succeed. That's the meaning of parts remain closely aligned in a high functioning system. So students, Azan is going on. Give me 3-4 minutes and I will continue the session. So that's the meaning of parts remain closely aligned, right? So let's go to this one, focused on achieving system goal. If it is a good system, their entire focus is going to achieve the goal, as well as it will make necessary adjustments when needed, as I mentioned earlier, right? So these are the characteristic of high functioning system ideas, right? So now let's move example to understand subsystems. You know, a pile of sand, remove a particle, still have a pile of sand, right? So it's simple. It's not a system, right? A pile of a sand. If you remove a particle, still have a pile of sand. It's not a system actually, right? What is system? A system is actually a functioning car. So a car, you can see in the pile of sand example also. And a system is a functioning car. If you remove the carburetor, no longer a working car, right? So that's system actually. So if you remove the subsystems, it's not going to work. So that's an example to understand the systems. Now you know about what are the high functioning systems, what are their characteristics, and what's the meaning of open systems, what are the characteristics of complex systems also. Now let's move to the IPO model, right? So IPO model in sense, okay, you're asking a question, okay, what's pile of sand? Okay, I'll explain that. So pile of sand in my dears, what I'm trying to say here, imagine a pile of a sand in a beach, right? If you remove one particle of sand, still have pile of sand. If you remove 100 particles, still have a pile of sand. If you remove half the sand, still have a pile of sand, right? Why it's not a system? Because the parts are not working together. There is no special purpose. There's no integration. Just a random particle sitting together. So that's not a system. That's what I'm trying to tell you, right? Now let's move to the IPO model. It means input process output model. As I mentioned earlier, every system contains a model made up with three major components, right? So those three major components are always, it's going to be the input. We have to put something into the system and we will process it and it will give the outcome. That's our actual purpose of being serving a system. So the input is the data as well as information that is entering into the system. And the processing means we are transforming the inputs as an information. So the output is always the results of the process, right? That's something we are considering as an IPO model. It means processing. Input is there and we are processing and we are getting some output. So we can have this as a here input and processor and output. So this is the actual boundary of this. Beyond that boundaries, we have environment. So boundaries and interfaces will be here and we will do some control in the processor. From the output, we will take the feedback and again we will adjust the input. So very simple thing, right? That is IPO model. And let's talk about this information system definition now. Why we have studied this? Why we have studied these complex systems, right? Types of systems, IPO, because we have to understand actually information system. That is actually our topic, not about systems. But without understanding the system, how can we understand the information system? That's what we have studied about IPO, complex system, what's the meaning of systems, everything. And now we are back to our actual topic, that is information system. So what this means by information systems, my dears, information system in this sense, right? You know, simply, we already know what a system means. Now we are adding the word information. So it's a system that actually deals with the information. Let's see the definition here. Information system is a system. It can be automated systems or manual system in the organization that delivers information and communication services needed by the organization. In simple words, it delivers information as well as communication. That's the information system. So the word information means the system is going to deliver the required information as well as communication in the appropriate organization levels managers, right? So here we mentioned the automated. What's the meaning of automated here? Automated systems or manual system. So automated or manual systems, in the sense, my dears, it can be computers. Computers are very automated machines, right? Or you can use a paper, right? And people. So you can use the automated or manual systems, right? Both are information system because both are going to deliver the information and communication. So don't think only the automations, machines and computers are information system. Even though manual systems with the people and paper also, it is an information system because they are going to deliver the information and communication. So organization, in the sense, part of the company, it can be school, hospital, or any organization. How they deliver the information and communication services, they provide the information when needed, and they help the people to communicate and take decisions, right? So this is the definition of an information system, ideas. There are components in the information system. Normally, we will have information technology, infrastructure, and application systems, and personnel who employ from information technology. So this is the information system elements actually. Simply, my dears, information technology infrastructure, in the sense, you can see in this particular picture in the image, simply the computers, networks, the servers, these are infrastructure. Without infrastructure we can't do anything, right? At the same time, application systems, in the sense, like software programs, we need software programs. That's an interface, right? The technology infrastructure is connected with application systems. And the people, the personnel who employ the information technology, those are the users, right? Right? People who use and manage the system. So this is the information systems elements or components. So there are three elements we are having. First is the information technology infrastructures, and the application systems and personnel who employ the information technology. Simple, right? And what is the purpose? The purpose of this information system. Why we need to have an information system? To deliver information to the users. So the purpose is deliver the information and communication service. That's the actual purpose. As I mentioned earlier, we are having a manual or automated information system to deliver the information as well as to communicate that information, right? It helps people to get information and talk to each other, as well as support the transaction processing or operations. They help with daily work like sales, purchases. They are going to support the transaction processing, right? That's what the reason we are having information system, as well as they are going to support the administration or management as well. They will help managers to make some decisions through their systems reports. So these are the important. So the every information systems, they have their purpose as well, right? There are purposes. So we have to understand the purpose. Right. As well as there are components, there are definitions. So simply, my dears, information systems are systems that's going to deliver the information and communicate that information in the organization. Right. Let's say some manual information system. That's a very old way. So Ahmad is having a shop in 1985. Ahmad runs a small shop in Peta in 1985. Okay, before long ago. So his information system is very manual. There's no computers. The components are, let's say infrastructure components. Let's say infrastructure components. What are the infrastructure he can have in 1985 without computers, without sophisticated things like now, right? What kind of infrastructure he can have? Notebooks, pen, calculator, filing cabinet. That is his infrastructure in 1985. And what about application system? His accounting methods are writing the sales and calculating the totals in the notebook, right? Who are the personnel? Ahmad himself, right? If the owner is Ahmad, so Ahmad himself, his son, if we have, right? So that is manual information system, right? How it works in manual system. So Ahmad opens the notebooks. He will write, okay, I sold 10 kilogram to Fatima. I have this and that, and he will write. And afternoon, Okay, he will write whatever the sales happen, and even he in the evening he will calculate. Okay, today's sale is okay 500 plus 250, so almost 2750, like that. This is also an information system, ideas. Why? It delivers the information. The owner knows his sales and profit. It supports the operation because he can track the transaction. It supports the management. Ahmed can make decision based on the information, but it's manual. It's time consuming. It takes hours to calculate. There can be so much of human errors. It's very hard to find any old information. Let's say an automated information system in modern way in 2026, the same shop. Now, with modernized systems and computers, what are the infrastructures? Now the infrastructure with one computer, barcode scanner, printer, wi-fi, cloud storage. So now the infrastructure is very big. What about application system? Now rather than pen and pencil, now point of sale system, POS software is there, inventory management system is there, very cloud based accounting software is there. And the personnel, who the people who use the computers, they are managers, they are systems, so many people. That's component. So you must know, information system is not only with computers, even it with people with manual things. If it is deliver the information and communicate in the organization, we can consider that as an information system. All of you get my point? Did you understand the topic elements of an information system now? Right? Now, let's move to 6 elements of an information system. Now we are going to categorize 6 elements actually, right? 6 elements of information systems. Actually, these are the elements. It will be in the question, my dears. You have to get ready with the question. As I can see you, this is very examination area. I can show you the exam frequency analysis also I have done. Here, out of your 11 exam papers available right now, 5 times it is tested. So 45 percentage probability, appearance rate. So it's very highly important area to understand these 6 elements. You can see the past paper breakdown I have done. In January 25, the question number I have mentioned. In January 24, July 22, January 22, January 21, right? The marks, they are allocating 2 marks, 3 marks, 4 marks, even 5 marks for a detailed diagram they have required. What are the question types? The question types identify the 6 components. Explain each components. You have to write down the components and their functions. You have to write a detailed diagram of this. Sometimes MCQ, basic identification of these 6 elements. So these are the kind of questions, as well as some additional related questions are there in July 2024. They have mentioned 6 elements with a detailed description. You have to ask for the 3 marks. So the marks range you can gain from here 2 to 5 marks per question. So averagely 3.2 marks. The highest marks is 5 marks in January 2022. You have to write with a diagram. So if you see my exam pattern analysis, the frequently asked to identify or list all 6 elements. January 2022 required a detailed diagram for 5 marks high value items, right? May ask for functions of each elements. Sometimes they will ask describe or explain each element. Sometimes it can be MCQ or detailed explanations. All 6 elements must be memorized by you. So the study priority is very critical according to my analysis. You have to memorize all 6 elements and be ready to draw a diagram with these 6 elements. Did you get my points, my dears? Now you can, I'll bet you, no any institute in Sri Lanka doing this kind of analysis. You cannot get this kind of quality of education, right? These are the core competencies and competitive resources we are making for our students. That's what we are getting island ranks, right? This time we have to prove with English medium, you are going to gain prize winners marks, right? Putting my shoe and my blood and shoe to make these contents available to you. So please study with a minimum effort. Please gain so much of marks. That's the only output of our system, right? Right. So let's learn about these 6 elements now. Simply software, hardware, procedures, people, data, communication. That's not a big deal, right? So software, hardware, procedures, people, data, communication. These are the six main elements of an information system. So let's talk about this one by one. Let's talk about element number one, that is software. What this means? Software is sometimes called the backbone of the hardware, right? Without software, we cannot use the hardware, right? Without it, the hardware would not have much use. It's just a metal, right? So that's the definition of software. So if we want to run the CPUs, fan, whatever the motherboard, whatever, we need softwares to support these hardwares, right? So software is the instructions, actually the instructions that tell the computer's hardware what to do, like recipes to tell you how to cook, right? It's a backbone of the hardware. Imagine you have a beautiful, expensive three-wheeler, but no driver. The three-wheeler just sits in your home. It's useless. The driver is like a software, gives instruction, makes it work, right? So now you got a very good understanding, I hope so. So what are the functions of this software? We have one, two, three, four functions. So let me number it. So we have one, two, three, and four functions here. It gives instructions to the hardware. It tells hardware how to function. It gathers, organize, and manipulate the data. So these are the functions of softwares. Let me tell you one by one. First ones, it gives instruction to the hardware. If you have some robotic arms like this or some digital printing machines, it will give instructions to hardware what to do, what not to do. And it will organize and manipulate the data actually in the hard drive or SSD drive. It will carries out instruction what to do. It will gather, organization, manipulates the data, right? So that's the instruction, the functions of softwares. So let's go with the characteristics, my dear. So what are the characteristics of this software? So everything you do on computer is done by the software. Whatever you are doing, interacting with the computer, actually you are interacting with the software, and the software is telling to the hardware, and we are getting the work done, right? Are you getting my points, guys? So everything you do on computers is done by software, right? So it consists of step-by-step instruction in a coding way. Sometimes the software is written by Python or JavaScript or HTML, whatever the language. It tells computers how to do its work, also called computer program, right? Computer programs. So we have Microsoft Office, Microsoft Word. Now we are using this software, the mind map software. Everything is a software, right? So now move to the hardware. That is the second element of the information system. What's the definition here? The most obvious part of any information system, the equipment that processes data to create some information. That's actually the hardwares, right? So hardware is the physical parts. You can see, you can touch, like the body parts of a computer system. It's very most obvious part, right? So what are the characteristics of hardware? It's controlled by software, as you know, and it's a physical components of the system. It's a physical component. Okay. So think of it's like hardware is like a three-wheeler vehicle itself. Software is like the driver, as I mentioned earlier. Driver is a software. It controls the vehicle. The vehicle is a hardware, right? So, you can see in every day the computers itself. That's a main machine, right? Desktop computers, laptop computers. You walk into any office in Colombo or dialogue office in Colombo, you will see computers on every desk. These are hardware, right? And you can see monitors, the screen that displays the information, right? Your phone, that's a hardware. When you go to People's Bank, the cashiers, they will look at the monitor to see your account, right? That screen is the hardware. The system units, the box that contains the brain of computer, a very big CPU, motherboard, RAM, right? Those are system units and servers, very super powerful computers that store the information and run services. If you go to Keels, Kiehl's has a huge servers in special air conditioned room because it will generate much heat. There is a separate room called server room. So these servers, they will store all the product information, customer loyalty card data, sales from all the branches, the inventory data. You never see these servers when you are shopping, but they are working behind the scenes, right? And sometimes, there will be some storage devices. So like that, we can serve a lot of examples, my dear. So as I mentioned earlier, computers itself, the monitors, the system units, servers, storage devices. Storage devices means what? Where the information is permanently served. Inside computers, inside laptops, there are hard drives or SSD drives. There are some USB flash drives, like small portable storage. And external hard drives are there, backup storage. Memory cards in cameras, digital cameras, we have memory cards in phones also, right? So if you are doing a, let's say, photography business in Candy, you take wedding photos with your camera. So camera is a physical hardware, right? Your photo is stored on the memory card. It's a hardware. You transfer your photo to the external hard drive for safety purpose. That's a hardware. Sometimes you will burn the photos to DVD to issue the DVD to customers. All these are storage devices as well as hardware, as well as smartphones, phones that are also computers simply. Your phone is a hardware, my dears. It has screen. That's a hardware. It has its processor. That's a hardware. Memory, camera, battery, everything is a hardware, no? As well as, tablets. Tablets means like a big phones, right? There are Mac tablets are there, right? iPad. We call that as an iPad. Like that mouse, a device to point and click, right? Printers, very self-explanatory things. So these are the hardware. And let's talk about the other elements of an information system, that is procedures. What's the meaning of procedures, my dears? Right. So procedures in the sense, that's very important part. It is actually the processes. The procedures provide people with rules, guidelines, instructions, and descriptions to follow, right? That's about procedures. Give me 1 minute. Right, so let's continue. So the procedures, it provides people with rules, guidelines, instructions, as well as descriptions to follow. That's about procedures. What this means, my dears, procedures are the instruction for the people. How to use the hardware, how to use the software correctly. Like, driving rules for three-wheeler drivers, right? So the analogy is here. The procedure element is the same to the people element. What software is to hardware, right? Yes, that's correct. So the software is telling to the hardware what to do. Like that, the procedures means what to do to the humans, to the people. Same analogy is here, right? So what this means, software tells hardware what to do. Procedures tells people what to do. That's simply the analogy. And the purpose is why we have to have procedures. It guide the users, it means actual humans, on how to use the system, provide instructions for operations, and document the best practices, right? Why documentation matter, my dears? You know, there is no, if there is no procedure, right, you might spend a lot of time by wasting your time, right? Let's say an example, you know, in dialogue office, okay, Ahmed, let's say Ahmed is a new employee at Dialogue Customer Service Center in Kandy. The first day there is no procedures, right? Customers are calling, okay, my phone bill is now 15,000, it usually only rupees 2,000, something's wrong. Now Ahmed is getting panic, and he's, very scary and talking, oh, let me, I don't know which button to press, let me try to this, click this, and he can click some random buttons and say, oh no, I closed the program. He's very nervous, right? And he says, sorry sir, I don't know how to fix this. Customers get angry. Customers say, call your supervisor, right? Ahmad can spend 20 minutes to trying out the figure out the systems. Customers are very unhappy, right? So we need procedures, my dears. In the second day, if same Ahmad have procedure, right? So there is a manual, right? Procedure manual. So supervisor gives him a manual. Okay, please go through it. And they are telling, okay, this is our customer service procedures. Procedures one, okay, how to check the bill. And in the document, they said, okay, step one, go to the customer account, click the customer database, type the phone number, enter it. And you will see the billing details. Click the billing history, select the correct month, and check for anomalies, like look for international calls, may be very expensive, that's the reason of huge bill. Or sometimes look for some roaming services or something, look for data over usage, automated bill. So you can explain the customers. When you explain the customer, there are procedures, okay, be very polite, show exact charges, and explain the each items. If there is any error found, right, you have to click the dispute bill button there, fill the form, submit to the manager, and please tell to the customer, okay, we will fix this within 24 hours. So this is the procedures in that manual. Okay, there are tips. Okay, always be very calm, friendly, check everything twice. If you unsure, please ask your supervisor. Never make any promises you can't keep. So this is the procedures, my. Now when new customer call, right, and say, okay, my bill is too high, okay, he will say very confidently after he know the procedure, okay, I'll help you, right, please give me some times. And he will follow the procedure. Okay, he will open the customer account, see the billing details, find the problems, and explain politely. Customers understand. Total time is just 5 minutes, customer satisfied, right? That's what the procedures are very important, right? So the procedures, it may be in user manuals, instruction for using the software, instruction for using the hardware, instruction for handling the data, anything, right? So these are the one of the elements of an information system. Must, we need it, must, right? That is one of the element. And let's talk about the other big element of an information system, that is people. What the meaning of this, my dears? People are the users and operators of the system, the most important element, human element, right? So let's see the definition here. The people who design and operate the software and the hardware, the end users, the final users, right? Connecting the softwares and operate hardware, right? End users. right? Probably the most important part of any information system, right? So probably the most important part of any information system is people, because without humans, still we have humans as a customers, humans as an investor, not robots, right? So the key point is people will determine whether or not an information system is going to succeed or fail, because people are the actual users. When they are using, if it is fulfill their needs, fulfill their purpose, yes, the information system is succeed. Otherwise, it's fail, right? So the people roles are very. So design the information systems. The people are designing the information system. They operate the software, hardware, right? They are the end users of the systems or the decision makers. So they have their own roles, right? So this is one of the element. And let's move to the another element, that is data, right? So data in the sense, it means the raw material that flows through the systems, the fuel that make everything work. Sometimes say to be the core part of any information system, that's the data, right? We have to provide the raw materials to function, right? So, my dears, there are key principles in the data. Hardware cannot work without software. Right? Hardware cannot work without software. Software cannot work without data, because we have to provide the data, the information. So the data puts the information into an information system, right? Think of it like a three-wheeler system. Hardware is the vehicle, software is the driver. What is the data? The passengers and the cargo. Without that, no need of hardware and no need of software. Without passengers and cargo, why have three-wheeler? The same way, without data, why we have to have an information system? So the data is everything, right? Let's say you bought an expensive computer in the peta shop for 150,000. Your month one, okay, computer sits on the desk. You never enter any data. So no sales recorded, no customer's name, no inventory amounts, no supplier information, nothing. So now the computer is useless, just expensive paperweight. Now, month two, okay. Ahmad's daughter, let's say Safia. Safia, okay, I will help you, Dada. I will do that. So she starts entering the data now. Every sales, the date, time, amount, item, customer, she is entering. All products name, quantity, supplier, cost, selling price, all customer name, phone, purchase history, all suppliers name, their context, prices. Now in the monthly, now computer is valuable. Why? Now, as an owner, Ahmed can now see which products sell most. He know when to reorder items. He can track which customers buy what. He can calculate the profit accurately. He can make some smart business decisions. So we must have hardware, software with the data. Then only it's a useful system. The data that made the difference, my dear. Right? So here the importance, no matter what type of information, data is essential for the system to function. Right? In every system, data is there. In dialogue system, the data are customer phone numbers, call records, data usage, payment history, customer address, package details. In hospital system, patient names, ages, medical history, test results, right? Medications, doctors prescribed, doctor notes, appointment schedules. In school system, students' names, their ID numbers, attendance records, exams marks, course registration, teachers' information. In digital accounting, my dears, your name, right? Which level you have chosen, which subscription plan you have choose, because according to the subscription plan, the course prices are going to change. Whatever the offer we are going to give you, it will be changed. Whether you have selected the books or not, what kind of books you have selected, whether you have selected the past papers or not, according to that we have to calculate your total amount. That's the data no we are collecting. Without the data, we cannot run digital accounting. There's no purpose, right? So the data is the most important element also. And let's talk about communication, right? Another important element, right? Communication allows that all parts talk to each other. System is a components of subsystems. So if components have to, communicate, then only the system will work. So communication allows the parts talk to each other like a nervous system in our body. Let's say definition, it allows multiple pieces of hardware to work together and enables information sharing also. That's the definition of communication. Simply, what's this mean? My dears, it allows multiple pieces of hardware to work together, right? Urgently, it's required sometimes, right? When information system need multiple pieces of hardware, yes, to communicate, we must need hardware. So it allows multiple pieces of hardware to work together and enable the information sharing. Why sometimes left out? Not always necessary for single computer systems, right? This communication, we need to communicate with so many computers, right? Not always necessary for only one computers. And it when required, urgently required when information system needs multiple pieces of hardware, right? So if computer system is having multiple pieces of hardware, we need this communication element. Let's say an example, one computer alone, we can work without any communication because everything within that one computer. So we don't need much communication. But multiple computers, we need communication to share the information. So if you are one person, doesn't need phone, right? If there are many people in far away, you need phone to communicate, no? Like that. The communication is matter, right? And what are the functions of this communication? It allows computers to communicate with each other hardware, and it exists between people who make hardware and software, and it disseminates the information to the relevant parties. It's internet widely used for communication normally, right? So these are the functions of this element. So let's see one by one. Allows computers to communicate with other hardware means what? Your laptop at home, it connects to printer to print. It connects to Wi-Fi router for internet. It connects to external hard drive for backup. It connects to phone to transfer the photos and PDF files. All it need communication. So it allows computers to communicate with other hardware. And what about access between people who make hardware and software? Let's say dialogue IT team. Hardware team install the new servers. Software team, they needs to know server specifications. They communicate via email, meetings, documents. So the communication should ensure the hardware and software are compatible with each other, as well as disseminate information with relevant parties. Let's say Food City. Food City, they are giving daily sales report. They are automatically sent to all branch managers. It's sent to regional managers, sent to head office. Everyone get informations they need. It distribute the information very efficiently, automatically. As well as internet widely used for the communication. Normally, for this communication, internet is required. Let's say Apico manager, they send the sales report to head office using the internet, right? They are using WhatsApp for quick team communication. They are using video calls like Zoom meetings between branch managers. There are cloud storage they are sharing like Google Drive, OneDrive to share the documents. They are having remote access like IT support. They are fixing the computer problems from remote location. They are, sharing the screen and controlling the screen, and they are fixing the issues. All they use the internet as a communication. So these are the functions of the element. And let's see the applications. Communication between computer systems is one application, and communication between people and remote access, data sharing, as I mentioned earlier, right? You can see the communication between computer systems, like banking. When you withdraw the money from People's Bank ATM in Colombo, that ATM communicates with the bank's central server to check the balance, with the transaction processing system to record the withdrawal, and with the card network to authorize that payment. All happens in seconds, my dear, milliseconds, via the communication networks, right? As well as communication between people. Let's say hospital, doctor in Colombo General Hospital, they can view the X-rays taken in the Kandy Hospital, sent via the network. They can consult specialist in London via video call. They send the prescription to pharmacy electronically. They can email the patient's family with update. So the communication that enables the modern healthcare, as well as remote access. What about this? Let's say you are a Food City manager at Dehiwala. At Sunday night, you are using your laptop to access the office computer in Colombo. You are in Dehiwala, right? You are checking the tomorrow's delivery schedule. You are approving the supply payments at your home. You are reviewing the staff schedule remotely, right? And data sharing. Let's say University of Colombo, the student registers online from home. The registration go to the admin system, and finance system gets the fees information. Library system add the student access. Exam system update the student system, right? Student list. So all systems share the data via communication. So these are the application of this communication element. So you must remember these 6 elements and definition and examples and functions, because this is more critical exam area, my dear. Right? I hope so. You are getting my points, everything. So I think today's session is enough, and we'll see with other session with the relationship between IT and IS and business process re-engineering. There are a lot of interesting stuffs are there in this topic. And let's see all of you in the next session. Have a great day. Thank you. Bye. See you.